So today we'll address this thing called Riemann sum, which is rectangle under the graph lah. So A level there was this here, right? When it come out, it's just they ask you to just explain how come this is that lah, without giving you any graphs and stuff. They ask you to draw. Okay, so I think that's where students fumble lah. But try to understand the concept. Okay, so I think there are a few core concepts there. So number one is okay, believe it or not, Riemann sum is essentially how you all the integrals that you do, right, is being defined by using Riemann sum. Riemann sum is like the first principle when it comes to creating calculus is embedded via this method. That's what I'm saying. Okay, you explore the limits. So there's one way to draw. This is let me see. Okay, left endpoints. Okay, great. So I think I'll use another one. Now, so for Riemann sum, right, you must understand there are a few ways of drawing it. You can either draw, guys, yeah, well, need to improve your math grade. Of course, I need to. So what you need to understand is you can take the upper bound, and then you can take the lower bound. And you say, what is this? Later I'll explain. So you can also take the middle. You can also take the trapezoidal, meaning this is actually essentially better than the typical one. But I think generally what we are dealing is upper and lower. Once you understand upper and lower, I think getting the trapezoidal is not that difficult because it's the same concept. So instead of using the area of a rectangle, you use the area of trapezium. Okay, so this one is not. So we are looking at this. So in this case here, what we are trying to achieve is this. We want to find the area under the graph of a given curve. Okay, so what we do is we draw a few rectangles. So this rectangle area here, do you see that is obviously an underestimation? Because the green color area is actually smaller than the white color, like the area under the curve, right? So, but what happens is if you increase the number of rectangles, it becomes closer to the actual area, right? So you must imagine that if you take more and more, right, this thing here, it's actually playing with large numbers, the limits. So you just sum all the way to infinity, it becomes the area itself. You see that this small jagged area here, okay? So that's the cool part lah. So you can actually Riemann sum from the left or right. Okay. So when we say left Riemann sum, what we actually mean is actually taking the boundary. So let's say this is fx, right? Okay. What equals fx? Left Riemann sum just means that I'm taking the area of the rectangle from the left side. Okay. So this case here, this will register. This is left side. The height of the rectangle registers from the left. Okay, from the left bound. So this one is this is f. The height is f0. Okay, this is it. So assuming that you are, so you would draw a few like that. Just draw it out. This rectangle. Draw it out. This one here. Just draw it out. Left bound. So typically the question will say they distribute it between 0 and 1. Let's say 0 and 1. And then this n rectangles are, so this is n rectangles here. 1 over n, 1 over n, 1 over n. Okay. So clearly, this one, when you draw it out, this is an overestimation. Okay. Agree is overestimation? Because there's this jagged area out. The jagged area here that you accounted for. Okay. That's overestimation. So this is how you calculate it. So left bound. This is left Riemann sum. So the next question naturally will be, if I always take the left Riemann sum, is it always overestimation? The answer is no lah. It depends on the curve, right? Depends on the curve. So this case here, if I were to draw this Riemann sum from the left bound, similarly, what I get is this guy here. you see that this is underestimation. So left bound, the height is registered from the lower bound. So it's a left Riemann sum. And so on. So this guy here, similarly, you register the height from the left side. You must be able to pick up all these nuances because in exam, I mean, you are there to settle by yourself. So this guy here is underestimation. Okay, here. So this is it. Similarly, the first height here is f0. Is 0. This is 1 over n. Is 2 over n. Is 1n minus 1 over n. Okay, there you go. These guys, you know that this is underestimation because of this guy here. They are all the missing area here. So you have an underestimation here. Okay, the region where you didn't account for. Okay. Now take note, when you write this down, what happens is that you have to be able to write it out in a sigma notation form. Okay, so the typical way, the only difference between, okay, so when it's left Riemann sum, right Riemann sum, is the either you take the height from the left or the right. So naturally, the way you write the sigma notation will be different. Okay, so I'm just going to continue doing the right Riemann sum, draw it out. I think we just do it as an exercise. Can you change this curve to the exponential also for the second one? So for the right Riemann sum, the height that you get is from the right side. So for every one boundary here, right, you actually, the height was registered from the right side. So this side here, this is 1 over n. This is 2 over n. This is 3 over n. This is 4 over n. Usually it's about 0 to 1. So this is n minus 1 over n. This is n minus 2 n. Minus 3 over n. Okay, guy we like that. Right side. Drawing is important because like I say in A level, it actually came out. So this guy, you see the first guy here is f. The height is f1 over n. The height that you register is f1 over n. So this is the height. This is the actual height. You all know f1 over n is the y value. The y value is the height, guys. The height is f1 over n for the first one. The second one is f2 over n. Subsequently, this guy here is f3 over n, and so on. And this guy here is f1 n over n if you want to lah. Okay, the height is important, so you're taking the one on the right. So similarly, this is an underestimation. Okay. So same thing, this is 1 over n, 2 over n, 3 over n, 4 over n, all the way to this is 1, this is n minus 1 over n, n minus 2 over n, n minus 3 over n. So this is overestimation. Okay, that's it. This width of 1 over n may not be standard. They may give you the width, but very likely they say divide by n rectangles, right? You just take it's just a normal arithmetic where because 0 to 1, right? So it's 1 over n. Yeah. If it's 0 to 2, then it's 2 over n. N rectangles. That's about it. You just divide based on the normal arithmetic. So this is underestimation because you lack all this thing here below. Okay, then this is definitely overestimate. This is underestimation, this is overestimation because all these jagged part. Okay, so these two, when you write them, left Riemann sum, you need to know how to write it, the sigma notation. Okay, Then for the right side, same thing lah. You need to know how to write the sigma notation. So they will mix and match the concept very, what do you call it, fluidly among these. Okay, sometimes they will use only the left. Sometimes the question will ask for left and right. Sometimes they will just ask for the right. Okay, but essentially the concept is all the same thing. It's just like that. So what we do is, remember, we want to ask to when to infinity what is the exact area. Okay, to infinity, the estimate, these are all estimated area. This one here, so the estimated area, all of them have a width of 1 over n, right? So the first height, the first rectangle from the left Riemann sum is f0. Agree? It's f0, right? Then the second one is 1 over n and so on. So the estimated area for left Riemann sum will be 1 over n f0 plus 1 over n f1 over n plus 1 over n f2 over n. You all know why, right? It's just base times height. Base times height. The height are all different based on the left bound because they take from the left bound. Okay, the width are all the same, so you can factorize this, and so very oftentimes Riemann sum comes hand in hand with sigma notation. Okay, this is n minus 1 over n, so this is 1 over n. Summation of r equals to 1 to n, usually 1 to n, so this is f r minus 1. For the estimated area of the, learn how to write it out, guys. Everything here you have to know how to write it out. It's not difficult. It's just writing it out. So estimated area for the right Riemann sum will be, you, instead of taking the left bound, which is 0, to determine the height, you take the right bound. So here, what we get is 1 over n f1 over n plus 1 over n f2 over n all the way to 1 over n fn minus 1 over n, the height of the last second one, f1. F1, you can see it as n over n. Okay, so this case here, replace it out. It doesn't matter which curve you start, left bound or right bound, as n goes to infinity, it definitely becomes the there you go, the area under the graph. Okay, so this is the other one. As n goes to infinity, estimated area will go to the integral of fx dx like that. For this case here, 0 to 1, it becomes the integral. Okay, so essentially you can write now as n goes to infinity, guys. You can write 1 over n. That is to say, i.e. to say that r equals to 1 f r minus 1 n would just becomes, both of them will equate each other. The left bound will be equals to the right bound. There you go. This is it. So this is the core concept for Riemann sum. The thing, this part of the math concept here is called, the problem name is called Riemann sum. Okay, of course you don't really see it in your school notes lah, because they usually write rectangle under the graph. Correct. The left one you start from, you end here because you start from 0. For the right bound, you start from the right, so you end at 1. So this is left Riemann sum. Then this is estimation from right Raymond sum.